Okay, when you're done with reviewing Newton's second law, 6.2, then pick up the 6b, Newton's third law. Now, the fancy way of saying Newton's third law is to say that for every action, there's an equal and opposite reaction, because this one's finally the one that makes sense. If you kick a ball, right, you apply a force to it, there's going to be a force applied to the ball and also to your foot. So the heavier the ball, the less fast it's going to go because of inertia. And then you can calculate that with acceleration as force divided by mass, so that if the ball's twice as heavy, it's going to move half as fast. So the third law just says that it finally introduces that other pair with it. So how we're going to do that today is we're going to set up a track like this, flat, just like you did the other day, except today you're going to need two cars. And you're going to put a rubber band around one car so that it fits across the back end like this. Now I think, just to keep everything the same, you should put a rubber band around the other car, but the instructions say you don't need it, but I did anyway. And then you're going to set the cars so that you get kind of a yin and a yang, so that the nose of one car goes into the tail end of the other car, right? You're going to put these cars on the track, and then you're going to put the photo gates, it says 15 centimeters apart. That's 3 circles apart. But what you want to make sure you have is that the wing of this car is just barely outside, and when then these two things are clipped together. So you're going to grab a clip that looks like this, and you're going to put it in the hole. Sorry about the camera work. And you're going to clip the two together like this. So you want to place the cars so that these two photo gates are about right in between the two. Okay, and how this works is when you get ready to shoot these two cars apart, you just pull up on the clip and the two cars flip apart. Now before you get started on the lab, pulling the two cars apart, once you've got it set up like I showed you in the previous video, there are a couple of questions that they want you to answer here on the second page, and I kind of wanted to help you through those. So the first question, what's causing the cars to move apart? Right? Think about it. Shouldn't be too tough. Okay? But there's got to be a force that's being applied. Where's the force coming from? And then B, according to Newton's third law, which again says for every action there's an equal and opposite reaction, right? How can we tell that, or how can we show that the cars are going to have an equal and opposite reaction by looking at the time? Well, kind of like we did the other day, right? What's going to happen to the time if the force is the same, right? That's what we're trying to prove. The mass of the cars should be about the same, right? So what should the speed of the cars be if the force is the same, right? Think about that for B. Now, when you come down to C, I want you to think about the same thing, right? What happens if the mass of the car becomes twice as heavy? Will they still experience equal and opposite forces? That's kind of a trick question. The answer is yes. They will experience the same force. But if the force doesn't change and the mass did, what do you think is going to happen to the speed? So the why or why not part of this is going to have to be, yes, they will experience the same force, but because the force is the same and the mass is now heavier, what's going to happen to the speed? So that's kind of what I want you to think about. Now, as you conduct the experiment, it's going to be kind of specific, and it doesn't really matter what order you do it, but the first time you do these two cars, you're going to have a car with no ball bearings in it, and then you're going to have a car with 2 ball bearings in it, and if you notice, they're spread in the front and the back of the car so that the center of the weight is still in the middle of the car. And then you're going to do the second trial is going to be no ball bearings and no ball bearings, so just like I showed you in the demonstration. Your third trial, you're going to switch, and I know this seems like it should be the same, but you're going to put the 2 ball bearings in the front car instead of the back car, or the left one instead of the right one. Okay, and then the last time you do this trial, you're going to do 2 in the front, 2 in the back. So you need 4 ball bearings today total for this experiment. You probably don't need eyeglasses. You shouldn't be throwing the ball bearings or flipping things very hard. Okay, be good to the sub and the pairs. If you need help again, if Mr. Ragsdale's gone, you can run down in Mrs. Geiss's room and ask Miss Conley to come in real quick. Right? I think it's a good idea to do 2 or 3 trials again. So as you put 0 marbles in the first ball and 2 marbles in the second ball, flip the cars apart 2 or 3 times and see if you get something that's kind of consistent. Right? You don't really need to take the average. I'd like you to do it more than one time for each box. And then when you calculate the speed, just because someone's going to ask, remember that speed is distance divided by time. And the distance is the 1 centimeter wing of the car passing through the photo gate, so the time is going to be either the time at photo gate A or the 1 centimeter wing traveling through the time at photo gate B. You don't need to worry about the time between the two cars today. Although the closer that thing is to 0, the more likely you are that you've got those two cars right in the smack dab center between the two photo gates. Okay, they're probably not going to be perfect times when they have the same weight, but they should be fairly close. Okay, when you're done with that, then go ahead and answer some of the questions once you calculate the speed. This one usually works pretty good, so the answers are hopefully somewhat obvious. Just remember, if there's two parts to the question, make sure you answer two things. Don't just put yeah.